Okay, example 2. All right, so now we are taking the derivative of everything, both sides, and then we've got a couple of things that we need to note. Uh, no implicit required there because that's in terms of x. This one is completely, and this is a mixture because we have a product, two things multiplied together. So I'm going to be very careful about that product rule right there. Half of that will create a dy dx. This one will create a dy dx, and the others will be normal derivatives since it's in terms of x. Okay, so here we go. The derivative of every single thing. Derivative of x with respect to x is 1. All right, now here's a product rule. First, 3x. The derivative of the second is y, so that's dy dx. By definition, it's the derivative with respect to x of y. So you just write it all together. Plus the second is y. We're still working in this red area right here, okay? And then the derivative of 3x is 3. Okay, so all of that right there was the derivative of this. Okay. All right, then minus, this is, we're going to act like it's a power rule, but watch what happens. If I say drop the power down, so I got -4, all right, y, which is not x, right? So anytime I don't write x, I have to do the chain rule to the first power, and then the chain rule is the derivative of the inside part, but the inside part is y. So it's dy dx. So you're like, oh, anytime you have a dy dx, I mean, anytime you have a y, and you're taking the derivative, you put a dy dx. That's true. You can say that without fail. But it's because of the chain rule. And the derivative of 2 with respect to any variable whatsoever is 0. So again, I'm going to gather all my dy dx's on the left-hand side. That's just what I prefer. So I have the 3x dy dx, and then I have a minus 4y dy dx, and they're on the left-hand side. And then on the right-hand side, I'm going to take the rest of the stuff, and they're both going to have a negative, so that's okay. So I have -1 minus 3y. Okay, and at this point, you can kind of see what's about to happen, but I'll go ahead and show it. I think it would be okay to either skip this writing and go ahead and know that you're going to factor out a dy dx. And if you're just the type that like to show everything, that's okay. But you could skip that, I think, and be perfectly fine. Or you could skip what I'm writing right now and go all the way to the division, because you know that you're going to factor out the dy dx and then divide by what remains. Well, what remains then is the 3x minus 4y. So I'm dividing both sides by that. All right. So that means the dy dx, okay, is equal to, and it's weird because it's a combination of x and y's. Well, that makes sense because so is our equation. Our equation is a combination of x and y's also. So I have to know an x and a y to be able to find out what the slope is on this thing. And this graph's probably insane looking. We're gonna look at one in a second that gives you the graph so you can see they're wild. A lot of them are not functions. I mean, they're just going all over the place, but yet you can still find slope, which is pretty cool. All right, so then I'll say, all right, well, dy dx at the moment, the x and the y are equal to both 1. That's what it's asking us to do here, by the way. And then I can show that substitution. You got to somehow show what you're going to substitute in. All right, and so this would be -1 minus 3. I'm putting y in for x. I'm sorry, 1 in for x at y. And so that's not hard to do. All right, so my numerator is -4, and my denominator is -1. And so my answer on this one is 4. And that's it. That's how you do it.